And we have x is equal to -5. But remember, now that we have our two solutions, 5 and -5, two possible solutions I should say, we have to make sure that they will be the domain, those numbers will be in the domain of both of these functions here. So let's do that. Remember that this, whatever goes into this right here, this whole thing right here has got to be greater than 0. Okay, so in other words, x minus 3 has to be greater than 0. And in other words, after solving for x here in this inequality, x has to be greater than, not 0, but 3. Lord. X is greater than 3. Alright. Well, 5 is greater than 3. So we know that 5 works, and 5 is greater, or 5 will work in here too. 5 plus 3 is 8, so that's greater than 0. But what about -5, right? So we can't plug -5 into here because we end up getting a negative number, and that's not in the domain. And we can't plug -5 into here because we get -2, and it must be, remember, greater than 0. So we're going to have to throw -5 out. However, we can use 5, and that would be one of our solutions. And of course, to show this, we could plug 5 in and evaluate each one of these, and it should add to 2 if we do that correctly. Alright, so I'll let you plug 5 in and evaluate those guys separately. And remember, in order to do this, you'll need to do log of x minus 3 over log 4. Okay, log x plus 3 over log 4, and then plug 5 in. Alright, and it should come to 2. Alright, well, let's look at another one. Let's see, what do we got going on next here? Okay, we've got log of x plus 1 equals log of x plus 9 minus log x. Alright, so of course we're going to condense this down. That'll be the first thing we do. Is equal to log of x plus 9 over x. Okay? Now remember, there's nothing written here because there's assumed to be a 10. Alright, we assume there to be a 10 there. Okay, well, let's get everything over to one side. Minus log of x plus 9 over x, and that's equal to 0. Alright, so now we have log of x plus 1 over, because this is a minus here, and we're going to put x plus 9 over x down in the denominator. And of course, we need to simplify this down. And we would simply do that by writing it like this. So this is that intermediate step, you know, that we went over earlier, complex fractions, I believe, in the complex fraction section. So right, so I took this and then flipped it, and okay, well, hopefully you understood that. Now remember, there's a 10 here. Okay, I'm just going to write this in. Let's get it out of log form, put it in exponential form. So this becomes 10 to the 0, and then we have, and I'm going to actually bring the x over here to the other side. It's more proper to write it like that. Okay, and save some room here, write it over here, and rewrite this actually. So we got x plus 1 over x plus 9 is equal to 1. 10 raised to the 0 power is 1. And then I'm going to continue this over here. And so now we have x times x plus 1 is equal to